So let's start things off with looking at molarity in terms of mass and volume. So this question I pulled out of the textbook, and it is, how many grams of solute are needed to prepare this 1 liter of this 2 molar NaCl? And the only note I made for myself for simplicity is that the molar mass of NaCl is 58.44 grams. So there's a couple things to think about that I want to emphasize here. First of all is looking at this NaCl. There's several videos I had you watch, and part of that was discerning the difference between ionic and covalent bonds. And I want to remind you that we have a metal and a nonmetal. So this sodium chloride is indeed an ionic compound. So I'm going to have these ions in solution, and this is my solute. So I'm going to need to figure out how many grams of this do I need to make 1 liter of this 0.20 molar solution. So let's just start this off with, I want 1.000 liters of this molar solution. So actually, let me be good with my habits. So NaCl times, this translates into 0.200 moles of NaCl per 1 liter of NaCl. So I can pause there and realize that I have these two volumes are volumes of the exact same thing. They cancel out. That puts me into moles. Well, I know that the NaCl has a molar mass of this 58.44 grams per mole. So if I put the 58.44 grams of NaCl per 1 mole of NaCl, well, then I see that my moles cancel, and I am left with this 0.2 times that 58.44. So the math trick here for putting things in your calculator, it's easy here because everything is 1 on the bottom. But if I didn't have a bunch of 1s, one thing I can do is put all of these values on the top and multiply straight across. So it would be this times this times this. Hit enter on your calculator and then divide by this times this. And that'll give you your answer. So this one, what does that come out to? 58.44 comes out to 11.7 grams of NaCl. So now let's ask ourselves a question of how many ions are in this solution. What is the concentration of sodium ions and the concentration of chlorine ions? That goes beyond what the book is asking, but it's an important concept to focus in on. So I have a full liter of this 0.20 molar solution. So that means I'm just looking at this 0.20 moles of NaCl per 1 liter. And I'm going to use 1 whole liter of that solution. Let me put my units in there. NaCl, NaCl. So now if I want to know how many ions, or what's the concentration of the sodium ions, well, I can look at this and I'll be like, well, I have 1 mole of sodium ions per 1 mole of NaCl. So that means that I have 0.2 molar or moles of Na+. Now, if I wanted to leave this in terms of molarity, well, then I would just ignore this value here, that 1 liter. And if I do start at this step, then I say, okay, well, I've converted my mole to moles to from my NaCl to my ion that I'm interested in. So that tells me that I have 0.2 molar of sodium ions. So my concentration of Na plus is going to be this 0.200 molar Na plus. And likewise, my Cl, I only have 1 ion there, so my concentration of my chlorine ions is going to be the same, 0.200 molar Cl minus. And that's important because you're going to see that we're going to work with several different combinations of ions, and sometimes we want to know what mass of sodium did I need to get to this 0.20 molar. So things are going to get a little more complicated. So let's have some fun. How about we'll go with, oh, that's why I can't see the question. There we go. I want 250 milliliters of 0.125 molar CuSO4. Okay, so I've written down the molar mass of copper sulfate, copper 2 sulfate, and this is what we want to know. So I want to know what mass of the CuSO4 I need. So go ahead and pause this and do that calculation yourself, and then come back. All right, so we're going to start with the same thing. I'm going to use 250 milliliters of my CuSO4. And let's see, I am going to take 250 milliliters of this 0.125 moles of CuSO4 per 1,000 milliliters of CuSO4. Now, if you're not comfortable with that step I just skipped, just let me point out what I just did, is that molarity is defined in terms of moles per liter. Well, 1,000 milliliters is 1 liter. So in lab, tragically you're not going to get to see this in person, everything we're working with is in terms of milliliters. So it's easier in terms of lab and what we do in real life to think of molarity in terms of that 1,000 milliliters. So let's see, I can look at this, I'm like, okay, so my milliliters canceled out. It'll leave me moles of CuSO4, and I already looked up the molar mass of this, so times 159.61 grams per mole of CuSO4, So I can look at my units. I have moles of CuSO4 canceling, so I'm canceling the correct units. And then once again, I'm left with just my grams of CuSO4. Everything is canceled out. And so that gives me 4.99 grams. So I needed 4.99 grams of CuSO4. All right, so now I want to ask you, how does this break down into ions? Is this ionic or is that covalent? What do you think? So I'm going to go with ionic, and the way I know that is I recognize this sulfate ion, and I want to emphasize to you as far as how many particles of ions I have in this solution. Well, let's see, I'm going to have Cu2 plus ions and SO4 2 minus sulfate ions. So I'm not breaking the bond. This sulfur-oxygen bond is covalent. We are not breaking that bond when we put it in solution. It stays as the sulfate ion. I cannot break covalent bonds with just water. So I have my Cu2 plus ions and my sulfate ions. And so this again, even though it looks like I have a whole bunch more, if I'm pulling out this 250, let's see, let's do the math. I'll write it out. I'm going to do 250 milliliters of CuSO4 times 0.125 moles of CuSO4. Actually, I'm just going to do this. So my 0.125 moles of CuSO4 per 1 liter of CuSO4. If I want to know the concentration of ions, so if I go just for copper 2 plus, then I would be, let's say I have 1 mole of Cu2 plus per 1 mole of CuSO4. There we go. So that tells me I have the same concentration. So this is the concentration for the entire solution, and it also gives me the same concentration of copper 2 ions and my sulfate ions. So I'm going to have 0.125 moles of this whole thing, but I'm also going to have that same concentration of my Cu2 plus and my sulfate ions in there. Now, if I take 250 milliliters of that, then let's see what I have. I have 250 milliliters. Let's rewrite that as liter, 1,000 milliliters. There we go. Now let's grab our handy dandy calculator. 250 times 0.125 divided by 1,000 gives me 0.03125 moles of Cu2 plus. Cool. Now let's take a look at sig figs. Now see, this question gave me 250.0, so it was actually written as this. So I have a 0, let me make that clear. I have a 0 trailing after the decimal, and what that's conveying to me is that I'm confident up to this decimal place. So I have 1, 2, 3, 4 sig figs. If that 0 here didn't exist and the decimal didn't exist, then I would only have these 2 sig figs. The trailing sig fig does not count, it's just a placeholder. So I have 4 here, but I have 3 sig figs here. Make sure that's what the book used. CuSO4. Yep, I only used the 3 sig figs here. So then that tells me that my final answer can only have 3 sig figs. So I'd have to write that as 0.0313 moles of Cu2 plus. For my mass here, that would have to be recorded as 3 sig figs, and it is. Up here, let's see, what do we have? We have 3 zeros after the decimal. So this has 4 sig figs, this has 3. So this answer can only have 3 sig figs. There we go.